Bismillahirrahmanirrahim. Assalamu alaikum dear students and my dear most viewers. Today I am going to solve this paper 1-2 of 9701, which is just recently came in the February-March exam series of 22. So watch this video till end so that each and every question is solved for you, and if you find any query, any doubts, you may leave your comments in the comment section. Before going into the question solving, let me brief you about my YouTube channel. You can find videos of the AS Chemistry 9701 in this YouTube channel. You will go to the playlist section, and here in the playlist section you can find various playlists already created. Here it is the GCE A Levels Chemistry 9701 lectures. There you can find that already paper 2 of the same February-March series has been attempted for you. You can find this video over here. It is of 43 minutes. So if you want to get the answers of paper 2 of the same February-March 2022 series, you must watch this video. So without wasting a single moment, let's start with the paper 9701-1-2, paper 1-2 MCQs based. As it is the first paper of the 2022 to 24, which is according to the new pattern, so in this paper you are provided with additional 15 minutes. You can see over here that 15 minutes were extra awarded, plus the question pattern has changed, that you don't have this section B here. Section B, which was based upon the multiple statement questions, multiple statement MCQs, that has been excluded now, so you won't be attempting those questions. So now it is a very much easier paper this time. So we will start from the question number 1. The question number 1 here states the first ionization energy of potassium K is 418 kilojoule per mole. The first ionization energy of strontium is 548 kilojoule per mole. Which statement helps to explain why strontium has greater first ionization energy than than potassium? So by looking at the values, we can see that potassium has this value and strontium has this value. We have to check the reason for this change in the reference. According to the literature, we know that going down the group, ionization energy decreases, and going from left to right across the period, ionization energy increases. We should know their positions in the periodic table. Let's see the periodic table as well. So we have this periodic table with us. We have to check the positions of the two elements which we are concerned with, potassium and strontium. So potassium is here and strontium is right over here. We can see that down the group the ionization energy should decrease and along the period should increase. That's the reason that the value of strontium is greater with respect to potassium in terms of the ionization energy. So let's see the options available here. What could be the reason? Number A says the charge on strontium nucleus is greater than the charge on a potassium nucleus. Yes, that is the correct. Why is that correct? Because the charge on the potassium is +1. It should be +1 by, we can say, by removing the electron, and the charge on the strontium should be +2. Greater the charge will give you decrease in the size. By increasing the nuclear charge, the size of the atom, which is R, decreases. So decrease in the size will affect on the ionization energy, and we will get a greater ionization energy. So this could be one possibility. Let's check other options as well if we find any other correct answer in these options. The outer electron in a strontium atom experiences greater shielding than the outer electron in a potassium atom. So greater shielding, greater shielding in strontium, obviously that is also correct. The shielding on the strontium is greater, but this should decrease the ionization energy instead of increasing. So this option, although the statement is correct, but it is not connected with this value 548, so we cannot say it is correct. The C option say the outer electron in strontium atom experiences spin pair repulsion. Spin pair repulsion, yes, there are two electrons in, because the group is 2, so there are two electrons in the valence shell of the strontium. So because of these two electrons in s orbital, the s orbital, which is definitely the 1 2 3 4 5 1 2 3 4 5, it is the 5s orbital. The 5s orbital has two electrons on it, so there is a repulsion, but the spin pair repulsion should decrease the ionization energy, but we are seeing a higher value, so it is also not correct option. D option say the outer electron in strontium atom is further from the nucleus than the outer electron in the potassium atom. Again, this is the same as that, the option B, that although the electron in the strontium is farther from the nucleus, so that is why we are getting a greater shielding effect. But again, farther from the nucleus means lower ionization energy, decrease in ionization energy, but we are getting high ionization energy, so it is again not correct option. So we are left with option A, that is the correct answer. So this is the correct answer of this option A. Now moving to our next question. 2. What is the electronic configuration of magnesium? Magnesium is present here. Let me remove the previous marks from here. Where is the magnesium? It is here. Magnesium belongs to group number 2. Its atomic number is here we can see that its atomic number is 12. The atomic number is 12, so we'll write 1s2, 2s2, 2p6. This is give you 10 and this is 12. There are 12 electrons in magnesium 12, but we are finding an ion here, so these two electrons will be removed from here, from 3s2, so that's why we will get this electronic configuration 1s2, 2s2, 2p6. So this is the correct option A, 1s2, 2s2, 2p6. Then comes the next question. Compound X contains the elements carbon, hydrogen and oxygen only. 2 gram of X produces 4 gram of carbon dioxide and 1.6 gram of water when completed combusted. What is the empirical formula of X? We have to find the empirical formula of X by using this value. So X is a compound composed of carbon, hydrogen and oxygen, and we are giving this value. So we know that a compound made up of carbon, hydrogen and oxygen is, let's suppose the value of C is X, H is Y and O is Z. These are the numbers of the atoms within the molecule. These are being combusted, this compound is being combusted using oxygen molecule. We write here O2 over here, and we are getting the products carbon dioxide plus water. We know that the number of atoms in this molecule X will be equivalent to number of moles of carbon dioxide X. So whatever the value we get here, it will be equivalent to this one. We say that 2 gram of X will produce 4 gram of carbon dioxide, so it is multiple of 2. 2 multiplied by 2 is equal to 4 grams. So if there is 2 gram of this molecule, then we are getting 4 gram of this, so definitely it is a multiple of 2. So I should write here that X is actually equivalent to 2. If it is 2, then again I will rewrite X, and I will write, instead of X I will write, let me do it correctly, I will write C over here and then 2 over here. So there are 2 atoms of carbon. Now I'm sure that the number of carbon atoms should be 2, so we are left with two options, B and C. Out of these two, the correct answer is any one of these two, B and C. Options A and D are now omitted. So let's see which will be the correct formula. If let's suppose that the molecular formula of compound is C2H4O, then I should be able to balance this equation. I should balance this equation to CO2. Now there are 4 hydrogens over here, then I can get balanced hydrogen atoms and oxygen by multiplying 2H2O. There are how many oxygen atoms on the product side? There are 2 into 2 4 plus 2 6. There are 6 oxygen atoms on the product side, and on the reactor side I have 1 oxygen over here and 2 over here. I can get 6 by multiplying this 5 over 2, 2, then I get 6 oxygen atoms on the left hand side. But if I suppose that the molecular formula was C2H2O instead, and I am reacting with O2, then I should also get balance equation to CO2 plus 2H2. Let me rewrite it, only H2O. I should write H2O over here. How can I balance hydrogen here? I have already balanced carbon atoms and balanced hydrogen atoms. How can I balance oxygen atoms? I have 3 oxygen atoms here, and I have, it is 3O. I have 3 oxygen atoms here, and I have 5 oxygen atoms here. How should I balance? I will definitely multiplying carbon with any value, and over here I will also multiply either this molecule or water molecule. So it will keep me going on forever to balance the equation. So that's why I can say this is not a correct expression, but this one is correct because I have balanced this equation very initially simply by checking the hydrogen atoms. So it is considered as correct molecule. So our option, the correct option would give me C2H4. Now moving to our next question. For which molecule is the dipole moment 0? The dipole moment 0 means all the dipoles must cancel out each other in the molecule. For that purpose, all the elements either should be same or they should have perfectly standard geometry or shape. CH3Cl is based upon 1 chlorine, 3 hydrogen atoms. So the dipole is not balanced because chlorine is most electronegative, then comes carbon, and then comes hydrogen. So it is not giving me the dipole moment 0. Then I have B option, CH. So I have again 2 chlorines over here, chlorine H, and 2 hydrogens. So these are not cancelled. Then in carbon, C option, I have CH and 3 chlorines. Again, they are not cancelling one another because they are 3 different elements. But in case of D, I have carbon with 4 chlorines, and these all chlorines will cancel each other because they are of equal electronegative value. So they will be cancel each other. So our correct option is D. Then comes question number 5. Which dot and cross diagram is correct for Al2Cl6? I have to check which one is the correct. So question number A says, the option A says ions of aluminium and chlorine, but Al2Cl6 is composed of the molecule and not the ions. So this is not correct option. Then B. Let's see what is in B. In B, I have chlorine with an aluminium bonded over here. So the electrons of aluminium are represented by X. So yes, it must be covalent bonding over here, covalent bonding between chlorine over here, and then covalent bonding over here. these are all the covalent bonds, and covalent bonds over here, here, and then over here. But what about the other bondings? We see that these two circles represent electrons of the chlorine, and these two circles represent electrons of the chlorine. So this shows a dative bond. Chlorine is giving its dative bond to the aluminum over here, and this chlorine is giving its dative bond to the is sharing its electron pair with the aluminum and forming dative bond over here. So this is just like a bond like this one. Aluminum has a dative bond with this chlorine, and this aluminum bonded to the chlorine is giving its dative bond with the aluminum over here, which was actually bonded with this one. And then again these are further bonded, and this aluminum bonded with two other chlorines, and this one with 3 aluminum chlorine, and this one again with 3 other chlorine. So yes, this is the correct options. This is the correct structure. Let's see in C option. We have covalent bond over here between chlorine and aluminum, and over here and here. But this is again another covalent bond, which is incorrect. There should be only 3. But in D we have this covalent bond and then this covalent bond, but this is not correct. The two aluminums are not actually bonded with each other, so it is again incorrect. So these options are incorrect. Our correct option is B. Then question number 6. The boiling points of some hydrogen halides are shown. Hydrogen halide with its boiling point HCl, HBr, and HI. So the values are showing the bonds between the hydrogen chloride plus the intermolecular forces. So we have to check what is the reason why the boiling point of HI is greatest than the other two. What is the explanation for the trend in boiling point for the hydrogen halide from HCl to HI? So the option A says the bond energies of the hydrogen halides increase from HCl to HI. Bond energy values, actually bond energy values decreases from HCl to HI. It doesn't increase, it actually decreases. The bond energy value decreases because of the increase in the size of the halogen atoms. Then option B says there is an increase in the strength of the intermolecular forces of attraction from HCl to HI. Yes, the intermolecular forces do increase. Intermolecular forces increases from HCl to HI because the greater the number of electrons, greater the number of electrons in a molecule, there is a greater intermolecular forces, and these intermolecular forces dictate the greater boiling point of the HI as compared to HI. So this option is correct. Then the C option says the intermolecular hydrogen bonds become stronger from HCl to HI, so there are no hydrogen bonds between the HCl or HI molecules. Then D option, there is an increase in the bond polarity from HCl to HI. And it doesn't actually increase, it decreases. Down the group the bond polarity decrease. So the correct option is B. Then comes the next question, 7. Elements X, Y, and Z are all in the first two periods of the periodic table. Their Pauling electronegativity values E and are shown. So they are the electronegativity values of these three elements X, Y, Z. Substances exist with formula Xz, Yz, and Z2. Which row puts these substances in order with increasing melting point? Increasing melting point means there must be an increased bonding between the atoms within the molecule. So let's say we have first molecule Xz. I have to check the polarity by this table. X and Z shows there is a difference of 3.0. So value of Xz is 3.0. For Yz we have these two differences. It shows it is of 1.9. it is 1.9, so I will write 1.9 here. Then comes Z2. Z2 means these is a bimolecular molecule, homonuclear bimolecular molecule, so there should be a 0 value here. So these polarity indicates their melting point. The greatest the electronegativity difference, the highest the boiling point. Xz has the greatest value, so we have Xz over here, and then we have lowest should be Z2, and we have these Z2 over here, and in between is the YZ molecule, so it is the YZ molecule, so the correct option becomes C. Then comes question number 8. The equation for reaction 1 is shown. Reaction 1 is this. What is the correct expression for the enthalpy change of the reaction 1? We have to find the correct expression for the enthalpy change. So basically this reaction is the enthalpy reaction where the combustion value for glucose is given and for the ethanol is also given. When when we have this type of the enthalpy change, enthalpy cycle, where the combustion values are used to find the delta HF, the delta H of the reaction, and we have elements which are also giving combustion product, and the main product is also giving the combustion product, then in this case we have this type of the equation to find the delta H of the reaction. Here delta H1 is this and delta H2 is this, so we can write it as products, which is delta H2 minus reactants. My mistake, it can be written as delta H1, which is the reactant minus products. So the enthalpy of the reaction would give you the value, will give you the expression delta H of the reactants minus delta H of the products. So we can apply the same equation of here, because we are getting the values of delta HC of the combustion. Again, here it is the main compound and they are its products. It is reactant, these are the products. So we'll write delta H of the reaction, which we have to find the enthalpy over here, delta H of this point. Delta H will give you the value of delta H of the reactants minus delta H of the products. By putting the value reactant, we have reactant here is A and the product is B. Although the product is B, but there are 2 moles of this over here, so we'll write 2 multiplied by B. But we do not include CO2 because this is a standard product of combustion, so we do not include the value of these compounds, either CO2 and H2O. So this should give you the final expression. So our correct option is D, A minus 2B. Then our next question is 9. Nitrogen monoxide is an atmospheric pollutant that is formed inside a car engine by endothermic reaction between nitrogen and oxygen. So this is the reaction between N2 and O2 to give you the 2NO. Which diagram correctly represents the energy profile for this reaction? Okay, so the statements say that this reaction is, as we say, it is an endothermic reaction. It is an endothermic reaction, so we'll check the profiles of the endothermic. Endothermic always have the value of the products. The value of the product is always in lower energy than the reactants. My mistake. The energy of the endothermic, the energy of the product is always greater than the reactants in case of endothermic. So these 2 options will be excluded because here the value of the product is less than the value of the reactants. Now we are left with option A and B, option A and C. Now we'll check which is the accurate picture of the reaction profile. So as we go from reactants to products, the activation energy is always written from the reactants to the top of the hill, peak point. So it is correct justification, correct representation. And then delta H is the value from reactants to the products, and the arrow head should be upward. We are calculating the value from reactants to products, so it is also correct. In case of C, we have E is from reactants to top of the peak. My top of the, so actually the correct option must be from these two options. Here the products is A and B. Sorry, the options A, we have to check A and B and not C and D, because these two belongs to exothermic reactions, and option A and D shows endothermic. Now in case of B, we check that the activation energy is shown correct, but delta H is represented downward from products to the reactants, which is incorrect. So this option A is the correct one. Now the next question is 10. Two half equations are shown. So this is the equation MnO4 with water and 3 electrons being gained. We are getting MnO2 plus 4HO negative. Then in the second case 2HO negative reacting with sulfide ion gave you sulfate ion plus water plus 2 electron being released. The equation for the reaction between manganate 7 ions and sulfate ion is shown. So this is the another equation. Which statements are correct? 1, 2 and 3. And then we are getting given the options A, B, C and D. This is very much likely with the it is very much similar to the multi-statement MCQs, because again in that type of the question we have multiple statements and then we have options A, B, C and D to check which combination of the statements is correct. So it is very much like similar to that one. Anyways, option A says 1, 2 and 3, option B says 1, 2 only, C says 1, 3 only, D says 2, 3 only. So we have to check if all of these options are correct or any of these. So for the time being, skipping the option A, we come to the option 2. Manganese is reduced to oxidation state plus 4. So manganese, definitely manganate was 7 initially. We can check their oxidation states. Oxygen has -8. The overall value is minus. So to balance this, the manganese oxygen state should be +7. So manganese is +7 here, and here the charge on the manganese can be found by checking this. -2 multiplied by 2 for the oxygen is -4, and the charge on the oxygen state on manganese is +4. So it is the change from +7 to +4 over here. So manganese, yes, that is correct. This one is correct. The oxygen state of manganese is reduced to +4. Then second option, sulfur, third says sulfur is oxidized from oxygen state +4 to +6. +4 to +6. So check the oxygen state on sulfur. Here it is 3 multiplied by 2 -6. So it should give you +4 over here. And in sulfate it will give you +6. So oxygen state from +4 to +6, it is also correct. Now we are left to find the validity of option A. U is equal to X is equal to Z. We have to check that the moles of U should be equal to X equal to Z. And how we can do that? We have to check this by modifying these equations, these oxidation and reduction equations. Now how we can do that? We have to check what is happening in these two reactions. As we know that there should be a balanced number of atoms, balanced number of charges on either sides. We have minus charge here, there is -4 negative on the left hand side, and we have -4 over here because 4 is multiplied with this. So we have -4. It is balanced. All the atoms are balanced, so it is balanced in that case. And for the second equation, we can check -2 over here, -2 over here, it is -4, and then we have -2 over here, -2 over here, so again 4. So these two are balanced according to the charges. But what about the electrons? According to electrons, 3 electrons are gained here, 2 electrons are lost here, so these are not balanced. To balance them, we have to multiply the first equation with the 2 and the second equation with 3. So I will write these two by multiplying these two equations with their specific numbers. Okay, now so I have note down all the equations by balancing them. Here we see that we check which species can be subtracted and added on by adding these two. The first equation was multiplied by 2, second equation was multiplied by 3, so we got these equations. Now we sum up these. By doing this, we check which species can be cancelled. This 6 electrons is cancelled with this 6 electrons over here, and then this 4 H2O should be subtracted from 3 H2O, so we are left with 1 H2O, which is written here, and then 2 OH negative is subtracted with this 6 OH negative, 8 OH, sorry, this is 8 OH and this is 6 OH, so this should be cancelled and we should be left with only 2 OH over here, so we are getting 2 OH here. Now we'll write all the species by adding them. We're getting 2MnO4, H2O, 3SO2. As the question was stating, we have to check U, V, X, Y, Z. So U is equal to 2, X is equal to 2, and Y and Z is also equal to 2. I'm writing, removing this U, X and Z. So these are all equal to 2. So this option is also correct. So this will give you give us the option A as the correct answer. Next question is 11. Hydrogen peroxide H2O2 decomposes to form water and oxygen. The reaction is catalyzed by bromide ions. Step 1 is bromide ions aqueous, H2O2 aqueous, hydrogen aqueous, water liquid bromine aqueous. Step 2, hydrogen peroxide aqueous, bromine aqueous, bromide aqueous, hydrogen ion aqueous, and O2 gas. What is correct? Which row is correct? Type of catalyst, and in step 1, type of catalyst. So the catalyst over here is the bromide ion. Bromide ion is written here. Bromide is written here. So we can know which one is correct, heterogeneous or homogeneous. We know that bromide would be heterogeneous if its state would be different than the other substances, but we see that it is also aqueous over here and other reactants are also aqueous. So because of this, we can say that this in step 1 is the in the same state, in the same phase like the other reactants, so it is homogeneous. So we have two options correct, C and D. Now we'll check in step 1. In step 1, what is happening to the bromide ion? It is changed from -1 to 0 over here, from -1 to 0. So this is definitely the oxidation. So the correct option should be oxidized. So option C is the correct one. Then comes the next question, number 12. Hydrogen and iodine react to form hydrogen iodide in an exothermic reaction. It is an exothermic reaction. Let's underline it. The equation is shown: H2 reacting with Hi2 giving you Hi. 1 meter cube reaction vessel contains H2, I2 and Hi gases at equilibrium. The temperature is changed such that the total pressure in the volume in the 1 meter cube vessel doubles. So it is now double. What is the net effect on the value of Kp and on the position of equilibrium? And we are giving these options: effect on the value of Kp and effect on the position of equilibrium. Okay, so how do we check the answer? First of all, we get some of the idea. The temperature is changed. The temperature is changed and the total pressure is double, and the reaction is exothermic. So as we know, the general gas equation, ideal gas equation, states that PV is equal to nRT. The temperature is directly proportional to pressure. The temperature is changed. The temperature is changed in such a way that the total pressure has been doubled, which means pressure has been increased. Pressure has been doubled, it means it has been increased. So as we see that pressure is directly proportional to temperature, so this temperature change is a positive change. The temperature is increased, so we write here temperature has been increased. This increase in temperature should be linked with the exothermic reaction as well. Okay, according to Lee-Chatelier's principle, effect of pressure should be studied. Effect of pressure and effect of temperature, both. According to pressure, the equation moves to that side which has least number of the moles. We have 1 mole here, 1 mole here, and 2 moles here, so these are equivalent. 2 here and 2 here, these are equivalent. So increasing pressure has no effect on the position of the equilibrium according to pressure, but the temperature was changed, and this temperature change was positive. The positive temperature, which means increase in temperature, should be linked with the exothermic reaction. According to this connection, increasing the temperature for the exothermic reaction shifts equilibrium towards the left. So when the equilibrium is shift to the left, we have some options here, and left moves left and left, so these two are correct. Then what about the value of Kp? Value of Kp, we can write the expression for Kp here. Kp is equal to partial pressure of Hi with its power 2, because it is written here. I should write here. It is in the power 2. I will write 2 over here, and then reactants partial pressure of I2 multiplied by partial pressure of H2. When the position of the equilibrium is moving to the left, it means we are getting lower concentration of Hi and higher concentration or higher partial pressure of H2 and I2. There is less pressure of Hi and higher pressure of H2 and I2. So putting here, Hi is decreasing and both Pi and H2 are increasing, so this will give you a smaller value of the Kp. So value of the Kp will decrease, so we'll say the decrease in value of Kp. So the correct option would become this one, A. Then the question number 13, we have diethyl zinc is added to sodium hydroxide. Two reactions occur, reaction 1 and then this reaction 2. In this reaction, which compounds act as Bronsted-Lowry acids? So acid, an acid is one which donates proton, H proton donor. This is the definition of the acid. So we'll check individually reaction 1 and reaction 2. In reaction 1, we can see that there are 10 hydrogens here and there are 12 hydrogens here. So this is actually increase in the protons of this compound. This compound has gained the proton from this molecule H2O. H2O releases protons to this molecule, so H2O will be an acid, H2O. And in reaction 2, we have 3 different reactions. Now we definitely know about OH negative. According to the definition of bases, all OH negative ions are basic. They are bases. If this is a base, then one of these two should be acid, and we see that there is no hydrogen here, no hydrogen, but there is hydrogen here. Again, if this is not an acid, then this must be an acid A, because hydrogen is being released by H2O, which is being accepted by the OH negative, and Z donor is also added with these two molecules at a time. So H2O is acid here and H2O is acid in reaction 1, 2. So we have this options corrected here. So option B is the correct answer. Question number 14. Which statements about atoms and molecules is correct? Option A. The molecular formula of a compound is the simplest whole number ratio of atoms of each element in the compound. No, it is not correct. Molecular formula is not the simplest. It is the whole number ratio. Then B. 1 mole of any substance contains 6 into 10 to the 23 atoms. No, substance give the molecules. Substance gives the molecules. C. The relative atomic mass of an element is the ratio of the average mass of one atom of the element to the mass of an atom of carbon 12. No, again it is not correct because it is not the ratio. It is simply the mass of an element is the average mass of one atom. Then D. The relative formula mass of a compound is the sum of the individual atomic masses of all the atoms in the formula. Yes, it is correct because relative formula is based upon the atomic mass of all the atoms in the formula. So it is correct. So option D is the correct one. Then question number 15. The Boltzmann distribution for 1 mole of a gas at temperature T is shown. Number of particles with energy E, and this is the graph. 1 mole of the same gas is added and the gas remains at temperature T. Which dotted curve shows the distribution with the added gas? So this graph has to be modified according to the given condition, which states that same gas is added. If the gas is added and the temperature remains constant, then this peak should remain at particular value of energy. If it is over here, then it should remain over here. There should be no shift in the peak, but the magnitude of the peak can be altered according to the given statement. So we see in option A that the peak in both the cases are at the same value, at this particular value roughly drawn over here. It is in the same position. In case of B, we have change in the shift, which is not possible because temperature is remain constant. Again, here we have change in the position of the peaks, and here we have change in the position of the peaks. So peaks are being changed, which should not be happening because the temperature is constant. So we are left only with option A. So option A is the correct one. Question number 16. In the direction shown, the concentration of both x and y are reduced to half of the original values, whilst keeping the total volume of the solution constant. X aqueous, y aqueous, giving the xy compound aqueous. Simultaneously, the temperature is increased from 298 Kelvin to 348 Kelvin. Which prediction is definitely true? A. A smaller proportion of collisions between particles of x and particles of y will be successful. So let's check. Smaller proportion of collisions between particles of x and particles of y will be successful. We have definitely half the original values. The concentration are half for both x and y. So yes, the smaller proportion of collision will be successful. It can be regarded as correct. Let's check the other value. The average kinetic energy of particles of x and particles of y will increase. The temperature has been increased from 298 to 348 Kelvin. So yes, it is also a correct option. Both the options can be correct. The C, the rate of the reaction will be unaffected. No, it is not correct because temperature has been changed, the concentration has been changed, so it cannot be remain unaffected. Then D, the frequency collision between particles of x and y will halve. Frequency becoming half is not correct because although concentration has been decreased, but at the same time temperature has been increased. So concentration has been half, but temperature has been increased. So it is not likely that the collisions will halve. So it is not correct. Now checking again A and B. What should be the most correct option? A smaller proportion of collisions between particles of x and y will be successful. It is definitely according to the concentration. The concentration was halved because then we say that smaller proportion, but again adding the factor of the temperature which was increased, we can say that those smaller, the new and smaller proportion of the molecules can now frequently collide with each other because of the increased temperature. So it is not very much true if we consider temperature. But in B, the average kinetic energy of particles of X and Y will increase. Yes, it is very much true, because by increasing the temperature, the particles will have greater kinetic energy. It is very much definitely true. This statement B is definitely true. So the correct option is B. Question number 17. A student investigated the chloride of period 3 element. This is what the student wrote down as a record. The compound was a white crystalline solid. It dissolves easily in water to give a solution of pH 12. When placed in a test tube and heated in a roaring Bunsen flame, the compound melted after several minutes heating. What can be deduced from this record? A, B, C, D. A says at least one of the recorded observation is incorrect. B, the compound was magnesium chloride. C, the compound was phosphorus pentachloride. And D, the compound was sodium chloride. So we have to match these observations with these compounds. If let's say we say that the compound was magnesium, then the compound should have these properties. It should be white crystalline solid. Yes, magnesium chloride is a white crystalline solid. It dissolves easily in water to give a solution of pH 12. No, that's not correct. Let's see in the literature. The literature says sodium chloride and magnesium chloride do not dissolve with water. Sodium chloride and magnesium chloride do not react with water. When they are dissolved in water, the cations and anions become surrounded by polar water molecules. And here we see that magnesium ions have +2 charge and smaller ionic radius than sodium. There is enough attraction between magnesium and her for coordinate bonds to form between these bonds. So when magnesium chloride is added into the water, we get the ions of the magnesium and chloride and no other product. So the pH 12 could only be possible if there was a very strong basic compound in the product side, which is not happening here, as we can see. And here we see the reason that concentrated magnesium chloride is slightly acidic. It says clearly the solution is slightly acidic, not the basic. According to the question, it should be basic. So option B can be omitted. It is not possible. Then C, the compound was phosphorus pentachloride PCl5. If this compound was phosphorus pentachloride, then let's see if it is a white crystalline solid, and does it give you the value of pH 12. Let's see it in the literature. The literature says PClC reacts violently with water, producing HCl with pH 1 to 2. So the pH is not basic, it is rather acidic, very much acidic. So this option cannot be correct. Option C is also incorrect. Then comes the compound with sodium chloride NaCl. So we saw that it has the same property like magnesium chloride. It doesn't give you the compound with alkaline compound, and it only gives you the cation. It only gives you the ions, sodium ions and chloride ions. So it is again not correct. So we say that option A is correct because at least one of the recorded observation is incorrect. Then comes the next question, 18. The elements in period 3 and their compounds show trends across the period from sodium to chlorine. Which row is correct? Electronegativity of the elements and the acid-base behavior of the oxides of the elements. So electronegativity of the elements do increase from left to right. So it is the trend. The electronegativity across the period from left to right increases. So it is clear here. And then the next column is about the acid-base behavior of the oxides of the elements. So we have to check this in the literature. Here it is acid-base behavior of period 3 oxides and hydroxides. So moving from left to the right, in the left side we have strongly basic, and in the aluminum case we have amphoteric, and the other elements show the strongly acidic. oxides and hydroxides. So we say that from left to right, the character changes from basic to amphoteric and then acidic. So correct option should be electronegativity increases. We have two correct options over here, and from basic to amphoteric and acidic correct over here, and basic, amphoteric and acidic correct options over here. So this correction, the real correct option is the C. Option C is the correct one. And then question number 19. The table shows the melting points of SiO2 and P4O6. These are the oxide SiO2 and P4O6. Melting points are these. Which statement explains the difference between the melting points of SiO2 and P4O6? So we have to check the reason for these melting points. The option A says the bonding of the oxide changes from ionic to covalent. No, there is no character of ionic over here. Both of them are covalent character. Then option B, the metallic character of the elements decreases across a period 3. Metallic character do decrease along the period T, but these two do not have the metallic character here, and they are, one of them is some in between the metal and the non-metal. So it is not the correct option. The metallic character has nothing to do here. Both of them are showing the covalent character over here. The oxidation number of the element increases from Si to phosphorus. So oxidation number of the element, it is, even if we say the oxidation number is changed from +4 to here it is the 6 to -6 +4 4 2, it is somewhere between +3 4 +2 2 to 4, it is about 2.5, somewhere like 2.5. So the oxidation number of the element has nothing to do with the melting point or the boiling point, because it doesn't show the type of the bonding. What about the D? These two options were incorrect, A and B, and C is also incorrect. Then D, the structure changes from giant molecular to simple molecular. Yes, it is correct. We see in the literature that the structure of this silicon, here it is written silicon exists as a giant molecular structure. Phosphorus and sulfur oxides exist as small molecules. So yes, their structures are different. Of sulfur, SiO2 is a very giant structure. Because of very giant structure, it shows very high melting point, whereas oxide of the phosphorus is a small molecule, simple molecular. That is why it has very weak forces between the molecules. So yes, the correct option is D. We choose the option D. Then comes the question number 20. Equal masses of calcium carbonate, calcium nitrate, barium carbonate and barium nitrate are thermally decomposed. The volume of gas produced in each experiment is measured under the same conditions. Which compound will produce the greatest volume of gas? So it is based upon the stability of these carbonates and nitrates. We have calcium carbonate, calcium nitrate, barium carbonate and barium nitrate. So we have to check what is their trend. According to the literature, it says that the thermal stability increases down the group. Barium carbonate will have greater thermal stability with respect to magnesium carbonate, and in case of nitrates we have the same trend written over here. The thermal stability of group 2 nitrate follows the same trend as the group 2 carbonates. So thermal stability increases down the group. So basically, if it is very much stable, then it will give less decomposition. Same case goes for the nitrate. If there is less decomposition, there will be less production of the gas. The carbonate compound shows this production CO2, whereas the nitrate shows decomposition into two gases, NO2 gas and O2 gas. There is a little mistake over here. It should be 2 over here, not 4. It is 2 NO2. So there are two gases in case of nitrates, and there is only one gas in case of the carbonate. So if we consider here, we can say that barium carbonate and barium nitrate will barium nitrate and barium carbonate cannot be easily decomposed, whereas nitrate and carbonate can be easily decomposed. whereas carbonate gives only one gas, whereas nitrate gives two gases, and out of these two gases, one of them has 2 moles and one of them has 1 mole. So there are greater amount of the gases production in case of the calcium nitrate. So the correct option will become B. And then question number 21. Which row gives correct comparisons between the solubilities of calcium hydroxide and barium hydroxide and the thermal stability of calcium carbonate and barium carbonate? So as we already discussed about the thermal stability in previous question number 20, that going down the group the thermal stability increases. So barium is in the lower position of the group, so its thermal stability is higher. It is the correct. This one is correct. Carbonate has lower. This one is correct and this one is correct. Whereas the solubility, what is the trend of the solubility of the hydroxides? Let's see in the literature. The literature says that the reactions of group 2 oxides and hydroxides with water. Here is the table. Solubility. The solubility of hydroxide of metal group 2 elements magnesium, calcium, strontium, barium. So going down the group, the solubility increases. So we can relate here that solubility increases down the group. So it should, barium hydroxide should have greater solubility and calcium hydroxide should have lower solubility. Now we can check which row is has all the options correct. This D, the option D is the correct one. Question number 22. Which statement relating to the elements in group 16 and their compounds is correct? Bromine will reduce Ki to form iodine bromine. Going down the group, the oxidizing power increases. So bromine comes first, and bromine and then iodine. Bromine is more oxidizing than iodine. So if iodide is present here, iodide is converted into iodine, then it is definitely an oxidation. Iodide is oxidized to iodine. So bromine is not actually reducing, it is actually oxidizing. So this one is incorrect option. A is incorrect. Then B, iodide ions react to form a white precipitate when added to silver nitrate solution. So let's see in the literature. The literature says when about is the iodide ion. When iodide ion is added into the silver nitrate solution, then we get the yellow precipitate of silver iodide. So it is the yellow precipitate and not the white. And then for option C, and the option C, it is B was incorrect. C say bromide ions react to form a white precipitate when added to silver nitrate solution. So bromide gives the cream precipitate, not the white precipitate. So again option C is also incorrect. About D, chlorine reacts with hydrogen to form a colorless gas. Yes, that is correct. When hydrogen reacts with the chlorine, we get HCl, and HCl is a colorless gas. So that is a correct option, D. Then comes the question number 23. The question number 23 states, an excess of chlorine was bubbled into 100 cm cube of hot 6 mole per decimeter cube sodium hydroxide. How many moles of sodium chloride would be produced in the reaction? So we have to check the reaction of chlorine with hot sodium hydroxide. So according to the literature, the reaction between sodium hydroxide and chlorine is this reaction. We can write this reaction as such to find the values. So I will write the reaction over here. Okay, so here it is the reaction. 3Cl2 reacting with 6 moles of NaOH to give you NaClO3 plus 5 NaCl and 3H2O. So according to the data, we have 100 cm cube and 6 mole per decimeter cube of sodium hydroxide. It is 100 cm cube plus it is 6 mole per decimeter cube concentration, whereas the chlorine is in excess. We have to find how many moles of sodium chloride would be produced. Moles of the sodium chloride, N is equal to what? So to know this, we have to first know the moles of the NaOH. So we'll find the moles of NaOH from the given data. As we know the equation, N is equal to C into V by 1000. We'll put the values over here. N is equal to C is the 6 mole and volume is 100 over 1000. Cancelling these two values, we get 0.6. The 0.6 moles of NaOH. We have this NaOH. Now we have to find the moles of the NaOH. Now we using the ratio method, ratio between the NaOH versus ratio NaCl. First we have, according to stoichiometric amount, we have 6 moles of NaOH and 5 moles of the NaCl, and according to given calculated value 0.6, we have 0.6 over here. So to know this, we find that 5 over 6 multiplied by 0.6, it is simple math. So this value will give you, it shall give you 0.50. So this is the calculated value of this expression. So we have this value over here. The correct option is B. I can write it with red. The correct option is B. Then question number 24. The product of the contact process is Z. Which reaction or process leads to the formation of a gas that can neutralize an aqueous solution of Z? Okay, so the product of the contact process is the process for manufacturing of sulfuric acid H2SO4. So the product Z is basically Z is the sulfuric acid. Now which product of these reactions can neutralize sulfuric acid? Definitely it should be a base. Only a base can neutralize this sulfuric acid. It is a neutralization reaction. Now we have to check out of these following processes which is giving us a base. In A, atmospheric lightning. Atmospheric lightning, as we studied, will always give either NO or NO2. These are the products of the atmospheric lightning. So these cannot neutralize sulfuric acid because these are not the bases. B, combustion of fuel in an internal combustion engine. Internal combustion engine will give us carbon monoxide, carbon dioxide, and NO2. These are the gases produced inside the internal combustion engine. So these are again not bases. The C, Haber process. Haber process is the process for the manufacturing of ammonia, NH3, and we have studied that ammonia acts as a base when added to water. So it is actually a base. What about D, thermal decomposition of group 2 nitrates? So group 2 nitrates, when thermal decompose, will give NO2 and O2, and these are again not the bases. So only option we get is the ammonia, because ammonia is a weak base. Definitely it is a base. So this is the correct option. Then question number 25. When ammonia is added when ammonia is dissolved in water, a small concentration of ammonium ion is formed. Which row is correct? Number of electrons in one ammonium ion and change of the HNH angle from ammonia to the ammonium ion. So we can find the number of electrons in ammonium ion. We have NH4 positive. NH4 can be written either like this, and we have a charge positive over here. So there are 7 electrons in nitrogen, 1 electron in 1 second and third hydrogen, but there is no electron in the hydrogen because this was a dative bond between nitrogen and the proton. So total will give you 10 electrons over here. There are 10 electrons. What about the angle? The angle over here is 109.5 degree, whereas in the case of the ammonia, which is NH3, the shape is trigonal pyramidal. Here the angle was 107.5. So there is a change from 109.5 to 107.5 degree. So there is a I'm mistaken. they change from 107.5 to 109.5. So there is an increase in the angle. So we have 10 electrons. These two are the options for 10 electrons, and the increase in the angle here and here. So these two are the correct options. So option D is the correct one. Then question number 6. In this question, alkenes and cyclic alkanes should be considered. How many structural isomers of C4H8 are there? So we have to draw the structural isomers of this compound C4H8. Structural isomers are those isomers in which there is a different sequence of the carbon-carbon link, carbon-carbon bonds, carbon-carbon chain within the molecules. So we have to make different combinations, different structural isomers of C4H8, and we can include these two options, alkenes and alkanes, cyclic alkanes. Cyclic alkanes and alkanes. So let's start from the cyclic alkanes. We have C4H8. So according to C4H8, I'm writing all the diagrams here. There must be 4 carbon atoms and there should be a chain. So C4H8, there are 4 hydrogen atoms which I am drawing with these blue lines. There, this is the structure for C4H8. This is one structure, first structure. Then I can write another structure, another cyclic structure. This one was the cyclic structure. I can write another structure like this: carbon bonded with another carbon. These are 3 corner structure. This is a propane, cyclopropane, and another carbon over here. And then by completing the hydrogens, 3 over here, 1 over here, 2 over, and then there should, yes, 2 over here, 2, 2, 4, 5, 6, 7, 8. So there are again 8 hydrogen atoms here. So this was the second structure. Now how can I write another way? There is no other cyclic chain possible for C4H8. So now I will shift to the alkenes. How can I write the structure of alkene? I have 4 carbon atoms linked directly to each other. Now I can include carbon-carbon double bond. I can include carbon-carbon double bond over here. Now if I write over here, then I can have 8 hydrogen atoms complete. How? 1 over hydrogen, and this is another hydrogen, 1 hydrogen over here, 2 over here, and 3 over here. Now total 3, 5, 6, 7, 8. So there are 8 hydrogen atoms. So this is the third structure. And what I have another combination. I can change the position of this double bond. So I will change this carbon, 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 and carbon. I have carbon-carbon double bond over here. Now again, completing the hydrogen atoms, there should be 3 hydrogens on this carbon, and 1 hydrogen over here, 1 hydrogen over here, and 3 hydrogens over here. So 3, 3, 6, 7, 8. There again 8 hydrogen atoms. So this one was the fourth structure. There is one other possibilities in which I can make a branch on this molecule by including the carbon-carbon double bond. How is it possible? Carbon, carbon, and this one carbon, and here is another carbon. Now I can include a double bond over here. This how many hydrogens over here? 1, 2 hydrogens over here. This carbon cannot include any other bond, so there is no hydrogen on this carbon, but there can be 3 hydrogens over here and 3 hydrogens over here. 3 plus 3 is 6, and then 2 8. So again there is 8. So this is the fifth structural isomer. So there is no any other possibility by which I can make another compound which will violate the rules of these structures. So there are only 5 molecules. So the correct option will become C, which is 5. Then comes the next question, 27. Which compound will decolorize bromine aqueous? Bromine aqueous has to be decolorized. So we know already that carbon-carbon double bond or carbon-carbon unsaturated carbon-carbon bonds will only decolorize the bromine. So we'll check which compound out of these have the carbon-carbon double bond or carbon-carbon triple bond. The first molecule is CH3, CH2, 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 COOH. So it is the carboxylic acid, and all the carbon-carbon bonds are single. And so A is excluded. B, CH3, CH2, 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 and CHO. It is aldehyde. It doesn't have any carbon-carbon double bond. Then C, CH3, CH, CH, CH2, 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 CH. Although it is an alcohol, but there is a double bond present at this point. So this double bond will give you the test, bromine water test. And the D says CH3, CH2, CH2, COO, CH2. This is an ester compound, and there is no alkene, there is no carbon-carbon double bond. So this again option is incorrect. So the correct option is C. Then question number 28. Alkenes react with aqueous hydrogen bromide. The reaction proceeds via an intermediate carbocation. The more stable the intermediate, the faster the reaction. Which sequence correctly shows an increase in the speed of the reaction with of the alkenes with hydrogen bromide? Ethene, propene, 2-methylpropene, 2-methylpropene, ethene, propene. So there are only 3 molecules with their sequence changed, and we have to check the sequence according to this increase in the speed of the reaction. So addition of the hydrogen bromide is according to the nucleophilic substitution reaction, and in the intermediate stage we get the carbocation. The carbocation will help us to find the correct sequence. Primary carbocations, as we can write over here, primary carbocation is slowest, then comes secondary carbocation, which is faster than primary, and then the tertiary carbocation is the fastest. Because they have said over here that the more stable the intermediate, the faster the reaction. The most stable intermediate is the we can write over here like this. Tertiary carbocation is more stable than secondary, and secondary is more stable than primary. So out of these molecules we have checked which is showing primary, which is showing secondary, and which one is showing tertiary. So ethene has this formula CH3, and writing the hydrogens over here. When the hydrogen is added into this molecule, the first product will be an intermediate with carbon-carbon single bond and carbocation over here, and because hydrogen has been added in this molecule over here, so there will be 2 hydrogens over here. So this is primary carbocation. I am writing here, this one is the primary carbocation. So ethene will give the primary carbocation. The propene, what about the propene? Let's write the formula for the propene. Carbon, carbon, and this carbon double bond. This will give me something like this: carbon, carbon, carbocation in the center, and this carbon. So this is the secondary carbocation. Propene is the secondary carbocation. And about the last one, which is the 2-methylpropene. So I can write its structure: 2-methylpropene, 2-methyl, and then this is propene. If it is the structure and this is the correct structure, then I can get the carbocation as this. I have carbocation over here, so this is the tertiary carbocation. So tertiary carbocation will give you the fastest reaction, So 2-methylpropene is the fastest, and we have to show an increase in the speed. The increase can be from ethene to propene and then 2-methylpropene. So as we can see here that option A has ethene, then propene, and then 2-methylpropene. So option A is the correct one. The next question is 29. Reaction occurs when a sample of 1 chloropropene is heated under reflex with sodium hydroxide dissolved in ethanol. Which row is correct? Type of the reaction and name of the product. Elimination and substitution, propane-1-ol and propene. Okay, so the reaction between a chloropropene in the conditions of reflux and sodium hydroxide dissolved in ethanol. So according to the literature, the formation of alkene is from halogen alkene is when the reagent is any halogen alkene and the condition is ethanolic, sodium hydroxide or potassium hydroxide. So there is a elimination reaction. In this case we can see over here that elimination reaction when ethanolic, potassium hydroxide or sodium hydroxide is used and the product is alkene. So the product and the type of the reaction is elimination and the product should be alkene, which is propene over here. So the correct option is B. And then question number 30. The diagram shows the structure of three halogen alkanes P, Q and R. P, Q and R can all be hydrolyzed. Which row is correct? Relative speed of hydrolysis, mechanism of hydrolysis. Okay, so we have a tertiary halogen alkane compound. In this case P is the tertiary, Q is a primary and R is also primary. So relative speed of hydrolysis, we know that reaction will have the greatest speed if the reaction has the stable intermediate, and tertiary compound will give you the tertiary carbocation, and tertiary carbocation has the greatest stability, which will give you this fastest reaction. So between Q and R we can check that Q is primary and R is again primary. So the comparison has to be made between two primary. Now within these two primary we can say there is a bond between carbon and bromine. Here we have bond between carbon and chlorine. So carbon and bromine is weaker than carbon and chlorine bond. This is weaker and this is the order according to strength order. When it is carbon bromine bond is weaker, then it can easily be broken. It can be easily be broken. So because of this this ease of breaking of the bond, it can give you the fast hydrolysis. So CBR between Q and R, this one is fast. Q is fast. Now mechanism of hydrolysis between P and Q. Q is primary, P is tertiary. So we know about the type of the nucleophilic substitution reaction. When there is a tertiary halogen alkane, it will give you the SN1 reaction, and when it is primary, it will give you the SN2 reaction. So the P is the tertiary, so it will give you the SN1. So option P, SN1 here and option 1 here. So the correct option becomes A. So this one is the correct option. The next question is question number 31. A sample of 2.30 gram of ethanol is mixed with an excess of aqueous acidified potassium dichromate 6. The reaction mixture is boiled under reflux for 1 hour. The required organic product is then collected by distillation. The yield of product is 60%. Which mass of product is calculated? So we have to understand this statement. The statement says ethanol is mixed with aqueous acidified potassium dichromate. The reaction mixture is reflux for 1 hour. So it shows that ethanol is being oxidized with the help of the potassium dichromate, and the product should be a compound, and we know from the literature that it is the oxidation of ethanol using potassium dichromate, and when it is reflux it gives you the ethanoic acid. So the main product is the ethanoic acid and not the ethanol, which is the aldehyde. Ethanol is not the product, instead the product is the ethanoic acid, because we are reflexing the compound. So the product, the reactant is ethanol to ethanoic acid. We are giving the data that 2.3 gram of ethanol was used, and we got 60% of the ethanoic acid. We have to find the mass of the ethanoic acid which is produced. For this purpose we have to make some calculations. First of all, We are given 2.3 gram of ethanol. Using the value of 2.30 gram of ethanol plus the molecular mass of the MR value, relative molecular mass of the ethanol, which is C2H5OH. It is equivalent to, we can now see 12 multiplied by 2 plus 6 plus 16. This is equal to 46. Then the mass of the ethanoic acid, it is the 2.30 gram was the mass was initially taken as, and this is the MR value of the ethanol. We can find the moles of the ethanol. Moles of the ethanol is equal to 2.30 divided by 46. It is equivalent to 0.05. Now we will calculate mass. We will find the ratio. We have to find the ratio between ethanol and the ethanoic acid, as we know that C2H5OH is converted into CH3COOH. In this conversion, there is no change in the moles of the reactants or the product. So whatever was the initial mole, let's say if it was 1 mole for ethanol, then it gave you the 1 mole of the ethanoic acid. So using the same ratio method, we can say that 0.05 moles of ethanol will give the 0.05 moles of the ethanoic acid. Now we have the value of moles for the ethanoic acid. Now we can convert these moles into the mass of the ethanoic acid to be produced. The mass, the MR value of ethanoic acid, CH3COOH, it is equivalent to 12 into 2 for the carbon plus 4 hydrogen equivalent to 4, and then oxygen will give you 16 into 2. Now this is equivalent to 60. MR of this ethanoic acid is 60. Now using the formula N is equal to M by MR for ethanoic acid, we can determine the mass. The mass will equal to M is equal to N multiplied by MR. The number of moles according to this ratio was 0.05. Now MR is 60 multiplied by 60. We get 3 over here. 0.05 is equal to 3 moles. Now these 3 moles are actually the yield when whole of the ethanol was converted into the product. But during the reaction, some of the minor products are produced. For example, carbon dioxide, my mistake, not the carbon dioxide, instead H2O. And during the conversion from ethanol to ethanoic acid, H2O is produced. This is a minor product. So because of the minor products, not all of the ethanol will be converted into the ethanoic acid, which means that this 3 moles was actually 100% yield when 100% of the ethanol was converted into the product, which is the ethanoic acid. But the question says about the 60%. So we have to find the value for the 60%. So we multiply this 3 with 60%, which is equal to 60 divided by 100 multiplied by not multiplied, simply 3 multiplied by 60 by 100, and it will give the value of, it would give you 1.8. So the final answer is 1.8. So our correct option is C, 1.8. The next question, 32. The structure of tartaric acid is shown. This is the structure of the tartaric acid. 4 moles of substance X react with 1 mole of the tartaric acid. What could be substance X? A. Sodium carbonate, B. C. Sodium hydrogen carbonate, and D is the sodium hydroxide. Okay, so we have to recall the reactions of these reagents with the this compound. This compound has 4 OH groups. It has 4 OH groups, and then it has 2 carboxylic groups, one over here and the second one is over here. So there are 2 carboxylic groups but 4 hydroxyl groups, which are actually the alcoholic groups, OH groups, basically OH groups. So we have to see how many moles of sodium and how many moles of other compounds can react with these. If we go to the literature, within the literature we can see that with reactions of carboxylic acids reacting with the metal including sodium or magnesium, we have sodium metal in our options of question. So if there is one carboxylic group, then it is reacting with one sodium metal. So one carboxylic group reacting with one sodium metal, and then reaction of carboxylic acid with alkali shows one carboxylic group reacting with one sodium hydroxide group, and then we have reaction of carboxylic acid with carbonates and hydrogen carbonates. 2 moles of the carboxylic group reacting with 1 mole of sodium carbonate, or 1 mole of carboxylic group reacting with the 1 mole of sodium hydrogen carbonate. So what we see from the reaction that in case of sodium, in case of sodium hydrogen carbonate, and in case of sodium hydrogen carbonate and sodium hydroxide, all these represented when one carboxylic group reacted with 1 mole of these substances. But we have to react 4 moles of the substance X. How can we get it? Sodium carbonate was totally incorrect because there were 2 moles reacting with the 1 mole of the carboxylic group. Now we'll check the reactions of the hydroxyl group with these substances. In our syllabus there is just a reaction of the hydroxyl group with sodium and not any other substance. So let's see the reaction. Here in the literature, reaction with sodium metal, this is the reaction of the alcohol with the sodium metal. So 2 moles of the alcohol are reacting with the 2 moles of the sodium, or we can say that 1 mole of the alcohol is reacting with the 1 mole of the metal. So this is 1-to-1 ratio between metals. Here in this diagram we had 4 moles of the hydroxyl, one over here, second, third and fourth. There are 4 moles of the hydroxyl groups. So 4 moles of the hydroxyl group can react with the 4 moles of the X if the X is the sodium. So that's how we can say that our correct option is A. 4 moles of the sodium are reacting with the 4 moles of the hydroxyl groups. So this is our correct option. The next question, 33. Which compound gives both an orange precipitate with tofu DNPH reagent and a yellow precipitate with alkaline I2 aqueous? Ethanol, methanol, propanol, and then propanone. So we have to recall how these substances can give positive tests with these 2 reagents. Okay, so for the let's say for the yellow precipitate with alkaline I2, the literature says that for this positive test, triiodomethane reacts with the compounds. What type of the compounds can react? Compounds like methyl ketones can give reaction, which have this group, CH3CO group. Ethanol, which has a CH3CHO group. Then aldehyde, which has this group, CH3CO. So these compounds which have this group CH3CO, only these compounds can give the triiodomethane test, iodoform test. So we can take some of the compounds, and we have another compound like ethanol and propanol. These compounds can give the triiodomethane, which again we have in case of ethanol alcohols we have CH3, CH and OH group. So we can take some of the reactants from these. Ethanol can give reaction with triiodomethane test, and propanol can also give the triiodomethane test, but neither methanol nor propanol can give, because only the ethanol can give the reaction. Now we have two options excluded. Now we'll look for the DNPH test. Now in the literature we can see the reaction of the 2 for DNPH is the reaction between aldehyde or ketone with DNPH is a condensation. So it is the reaction of the aldehydes and the ketones with DNPH. So any aldehyde and any ketone can give you the DNPH test. So we can see from here that we have only one ketone mentioned out of these options A and D. We have these two options. B and C were already excluded because of the second point, but for the first test, this test number 1 and this test number 2, the test number 2 is carried out the test number 1 is carried out by the propanol, and also this test number 2. Both these tests are being carried out with by propanol. So our correct option is D. Then question number 34. A student suggests two uses of lithium aluminum hydride. Reaction 1, it is a propene reacting with the lithium aluminum hydride as a catalyst to give you the propane, and reaction 2 is the ethanoic acid reacting with the lithium aluminum hydride to give the ethanol. Which reaction would give the product shown? Both reactions, reaction 1 only, reaction 2 only, and neither reaction. Okay, so we know the use of the lithium aluminum hydride. It is a very strong reducing agent. And it reduces the other compound by providing its hydride ion within the lithium aluminum hydride. This hydride ion is able to reduce the carboxylic acids into the alcohols. We have studied the reaction where lithium aluminum hydride can reduce the carboxylic acids, but it is not able to reduce any alkene compound, because for alkene we need hydrogenation with the help of the hydrogen in the presence of the platinum and palladium compounds. Platinum and palladium compounds are needed along with the hydrogen molecule. So this reaction A is not possible, reaction 2 is possible. So our correct option is C. Now our next question is question number 35. Compound X contains a single ester group. X contains 27.6% by mass of oxygen. Which pair of products could be produced by the hydrolysis of X? So hydrolysis of X gives you butanol and ethanoic acid, ethanol and propanoic acid, methanol and methanoic acid, and this. Okay, so we have a compound X which is an ester, and hydrolysis of ester gives two products. One part gives the carboxylic acid and the second part gives the alcohol. Now we have to determine what is the structure of that X, and to check that structure we are given this data 27.6% by mass of the oxygen. We can confirm our structure by this value. So we can give a hit and trial base. We can start like this. We have a CH3 group, and then we have this an ester group within this chain. We can check the percentage of oxygen by making a long chain. Let's suppose I make this compound. This is whole of the ester group. If I make this compound CH3CH, this whole, I can find the MR value of this whole compound. The MR can be found by writing its molecular formula. How many carbon atoms here? 1, 2, 3, 4, 5, 6. There are 6 carbon atoms, C6 hydrogen atoms are 3, and then we have 2, 5, 3 to 5, 7, 9, 9 plus 3, 12, H12. There are 12 hydrogen atoms and oxygen atoms are O2. Finding its molecular formula Mr of this compound, it will give 6 multiplied by 12 plus for hydrogens 12, and for oxygen it is 16 multiplied by 2. Now this will be equal to 1, 1 and 6. Okay, so this is the value of the whole of the ester group. Now we have to check percentage by mass of oxygen. We can get this value by adding the masses, by dividing the mass of the O2 divided by Mr of the ester. It is equal to mass of the O2 was actually this 16 multiplied by 2. It is equal to 32. 32 divided by mass of the oxygen, mass of the ester, which is 116. So this will give you the value. Since this is a percentage, we can multiply this equation with 100, so it will give you 27.6%. So this is our correct structure of the ester. This is the correct structure. Now what should be the products after hydrolysis? We can get two products by cleaving over here. This part will become the alcoholic part and the other one will become the carboxylic part. So how many atoms of the carbon are here? 1, 2, 3, 4. There are 4, so it should be butane 1-ol. It should be butane 1-ol. The other part should be ethanoic acid. So our option A is the correct one. Butane 1-ol and ethanoic acid. All the other options are wrong. Then our next question is, what is the least number of carbon atoms in a non-cyclic alkane molecule that has a chiral center? Chiral center means it is that center, it is an asymmetric center which has 4 different groups of atoms attached to it, either atoms or group of atoms. That is called a chiral center. So we have to find a carbon molecule, an alkane molecule. It should be an alkyl molecule and it should be non-cyclic. So how can we find? Let's suppose we have a carbon over here. This carbon should have 4 different groups. I will start from the smallest value, from the smallest atom. The smallest, it can be any atom like hydrogen, because it should be an alkane. So alkane can have only hydrogen and carbon. So the first group is hydrogen. The second group I will write carbon. I should change the color so it will become more clear. The second group is C and C. Then I can draw another group. It could be another chain, but this should be different than the rest of the two. Now we are left with one more group of atoms, and that group of atoms should be different from these 3, and we are left with only one possibility, that is an increase in the number of the carbon chains. If there were 2, then 3, then I will write 4. There are 4 carbon chain of the 4 carbon atoms. So this central carbon has now 4 different groups attached to its surrounding, attached to it. This group is different from this one, and then this one is different from the previous 2, and then we have this last one of 4 carbon atoms. So we have a chiral center with 4 different groups of atoms attached. Now we calculate how many carbon atoms are here present. 2 plus 3 5, 5 plus 4 9, 9 plus central carbon 10. So there are 10 carbon atoms. So this is smallest, this is the least number of carbon atoms which we can get to get the chiral center. So our correct option is D, 10. Then next question 37, a molecule of polymer contains the sequence shown. This is the sequence: carbon, hydrogen, Cl, CH and Cl, CH and CHH. Which monomer could produce this polymer by addition polymerization? Okay, so we have to find the monomer which can give you this polymer. So starting from A, we have this molecule CH and Cl double bonded with carbon with CH and Cl. Let's suppose if it is the monomer, then we should get arrangement by removing this double bond sign over here. We should get either CH Cl like this, another attached with CH Cl, but this is not the case. We are not getting this structure in anywhere in the polymer, so this is not correct. What about B? If we check B, I have to write over here C with 2 hydrogen atoms, then C and double bond C with H, and then this is Cl. Let's suppose if it is the monomer, then I can combine this with another similar molecule. If I write carbon over here and another molecule of CHH over here, and then C with Cl over here, and then I write another molecule with Cl, and this is the, and there is a little mistake, it is not Cl, one of them is the hydrogen, so CHCl. I can make multiple monomers combined, CHCl, and then we have CH. So these are different arrangement. I can find this arrangement in the polymer molecule. We have CH2 and then another carbon with CH2 and then CHCl and then CHCl and then CH2 and then CH2 CHCl. So these is the same arrangement which we can find from here. CH2 CHCl, this is the CH2 I can find from here, this is the CH2, this is the CHCl, then CH2, another CH2 over here, and this is CHCl. So this is the monomer present over here. This monomer belongs to this, and this also belongs to this. CH2 CHCl, CH2 CHCl. So this is the correct option, B, because I cannot find another combinations or from these two options, C and D. So the correct option is B. And then question number 38. Compound Y is heated with a mild oxidizing agent. One of the products of the reaction reacts with the hydrogen cyanide, forming 2-hydroxybutane-nitrile. What is compound X? Okay, so what is compound Y? What is compound Y? We have option butane 1-ol, butane 2-ol, propane 1-ol, and propane 2-ol. Okay, so we have to find the product 2-hydroxybutane-nitrile when it reacts with the compound Y. If we check in the literature that butane-nitrile only reacts with the we get this compound hydroxybutane and nitrile when HCN reacts with the aldehydes and ketones. Only these give the product hydroxy compound hydroxybutane-nitrile. And how do we know that it is the which compound is giving you this product 2-hydroxybutane-nitrile? Let's suppose if it is the butane, if the product was initially propane 1-ol, then it must give you the product aldehyde, because we are firstly reacting compound Y with the mild oxidizing agent. So propane 1-ol, let's suppose starting from C, propane 1-ol, CH3 CH2 and OH. If I remove if I go it through the oxidation, then it will give you the CH3 CH CH2COOH. It is giving the aldehyde group. Now this will react with the HCN. When it reacts with the HCN, then the product will give you CH3, CH2, COH over here, H over here, and this is CN. If we name this compound, it will give you 2-hydroxy butane nitrile, which is our real compound mentioned in the statement. So we can see that propane 1-ol has been converted into propanol, and this propanol, when reacted with the HCN, gave you the 2-hydroxy butane nitrile. So our correct option is C. All the other options will not give you the 2-hydroxy butane nitrile, they will rather give you another product. Now moving to our next question, number 39. The diagram shows the structures of lycopene and beta carotene. These are their structures. When lycopene is converted into beta carotene, what is the gain or loss of hydrogen atoms per molecule? So we have to find if there is any change in the hydrogen atoms in these two molecules. Let's see. If I zoom it and find any change, what do we find here? Starting from the very start, we have this CH3 on the lycopene and CH3 in the beta carotene, but there is a difference over here. This thing has been changed into this thing. There is a difference over here, and similarly we have some differences over here and here. We have differences over here. We can check if there is any loss of hydrogen or gain of hydrogen. How do I check this? Because rest of the structure is the same, there is no any other change, only there is difference between these points. I will check if there is any change in the hydrogen atoms. Initially there was no hydrogen at this point. There is no hydrogen, but there is one hydrogen atom present over here, and in case of this point we have one hydrogen atom over here. If this is converted into this part, then we have two hydrogens present at this point, whereas there is no hydrogen at this point. So this, you can see that this hydrogen has been shifted to this point, so there is no change in the hydrogen atoms. Likewise, if we go on the other hand, this point has one hydrogen atom and this point has no hydrogen atoms. But if I check here, we have here no hydrogen atom over this point, but we have moreover there was one hydrogen atom over here, where we have two hydrogen atoms present over here. So we can say that this hydrogen has been moved to this point. I can actually remove this point because there was no hydrogen atoms at this point and this point. These are the same, so there is no change in the hydrogen, only there is a shifting of the hydrogen atoms. So we can say that there is no change. This is our correct option. Now the last question of this paper is question number 40. Which diagram shows the infrared spectrum of a compound that contains both a carbonyl and an OH group? So we have 4 different spectra of the IR spectrum, infrared spectrum, and we have to check. Okay, so we can find the values of the peaks by matching the wave number, and we have the table given here. The OH groups belongs to 2 compounds, carboxyl and hydroxy, and they have their ranges present here: 2500 to 3000, 3200 to 3650. If we say that there should be very intense peaks present to give you the real compound. According to this, carbonyl group is present in both hydroxyl the carbonyl group is present in carboxyl and all the other compounds. First of all, we have to check the position of the OH group, and OH group is in these ranges 2500 to 3000 and 3200 3650, and the peak should be very much intense. So we can see here in the option A that it is not very intense, so we can exclude this option A. But OH groups are present in all these options C, B and D. OH group is present in all these cases. Even here it is very much weak. Now we have to find the carbonyl presence. Carbonyl is present in all these compounds: amide, carbonyl, carboxyl and ester, and they have the values in these ranges 1640 to these molecule and these ranges. Okay, so how do we know which of these spectrum is the real one? If we check the, if let's suppose if it was a carboxyl group, then carboxyl group should give you the ranges 1670 to 1740. So there is an intense peak over here, about 1640. It does lie within the range of the 1670 to 1740, whereas here it is also present over here, somewhat here like, but the hydroxyl range is not that much. It is very weak in this case, it is not present, and it is again not in that point. So we can also check the peaks with the literature. We have here the peaks of the carbonyl and the hydroxyl groups over here. We can see that OH group is present in case of the ethanoic acid, and its peak is ranging, it is showing deep valley like this. So it is the peak of the OH, and the other peak we have over here is that of the carbonyl group. So as we can see that this is very much clearer, it is very much similar to the one we have seen in the question. This peak, carbonyl peak, is very much intense, which is present over here, and although it is present over here too, but the OH group is not like this. It is not very much sharp, it is always a broad. OH group will give you the broad peak, so it is not correct. And over here this was one was correct. There was no pH, there was no peak for the OH over here, and neither, but there was a peak for the like somewhat like for the carbonyl. So the only option we are left with is the B option, because it is the same peak which we can see over here, OH group and C carbonyl group. This includes both the carbonyl peak and the OH group peak. So correct option is the B. So this is where our question completes. I hope every question has been answered very clearly and no question has been left unattempted. If there is still any inquiry, any doubts, you can ask me in the comment section, and I will definitely answer you very shortly. Keep in touch with my YouTube channel, and I will keep solving more of the question paper with the passage of time. And again, if you find this channel very helpful, do subscribe it and share with your circle, with your friends. And again, I will tell you, I have created a playlist section where you can find different videos of the AS and A level chemistry, and this video is the part 2. This video is for the paper 2 of the same February-March 22 series, so you must go through this video as well. Alright, till then, do take care of yourself. We'll meet again, so take care and Allah Hafiz.